Hello, everyone. I'm glad to have the opportunity to share my thoughts on privacy enhancement technologies and some of our ongoing open source code project. Until this year, eBay has been launched and in operation for 30 years. We witnessed the involvement of privacy regulations over the past 30 years. In the beginning, there are little or no regulations for customer data protection. It is normal that the customer data be used directly for analysis. As some and more customer data being abused, people started to get the awareness that they should know how their personal data is collected or processed. Regulations like GDPR, CCPA, Schrems II started to enforce companies to protect customers' data. While the customer data is protected, it is difficult to analyze and get the insights of customers. It is definitely a challenge to keep both data utility while preserving the data privacy. It's like you want to know the insights of the customer data, but you are not allowed to see the customer data. As a pet lover and a privacy architect, I have been thinking about the ultimate goal of pets. I found there are a lot of similarity between what we want to achieve with pets and airport trained dog. So there's tons of customer luggage waiting to be scanned for dangerous materials, such as drugs or explosives. The luggage cannot be opened due to the privacy concerns. While people are still developing advanced scanning technologies, dogs are still being adopted to conduct this task. Considering the whole process from a privacy design perspective, the dog actually did a pretty good job. First, the whole process is anonymous. The dog doesn't have any knowledge about the owner of those luggages. The dog is trained to be solely interested in the smell of a few particular particles and nothing else. Second, confidentiality. Dog doesn't speak. It can't sell the information it collected for profits. They can't even note down the PI data in any persistent way. From the cryptography perspective, the efforts to train a dog to disclose the personal materials in the luggage by which people can identify the owner of the luggage is so high that we can safely ignore this risk. It is a perfect model for data protection, for data at rest, in transit, and in memory. Second, end-to-end integrity. Dogs don't open the luggage, so the risk of stealing items from the suitcase or moving the items from one suitcase to another suitcase is fairly low that we can ignore. The suitcase is kept untouched. You don't need a HMAC or signature to protect this integrity. The way that dogs detect the smells of dangerous materials is well understood. This is about the transparency. And this fact is based on the biologically developed capabilities over thousands of years. With proper training, all the reaction from dog can be explained with the right transparency. The last one is accuracy. The accuracy of dog detection is fairly high. It is even higher than a lot of human-developed artificial smell scanner. We didn't understand the smell system as well as the visual system. Okay, now let's get back to the privacy world. Why do we need pets? It's mostly because compliance reasons. Different compliances mention pets to address their different goals. For example, White House Executive Order 14117 requires a very stringent data protection for U.S. customers' data being transferred to a list of countries. It mentioned homomorphic encryption to process customer data without showing the plaintext of it, It also mentioned differential privacy to avoid individual customer being singled out. EU AI Act is an AI governance published recently to regulate AI training. As we know, a model tends to memorize. So if there are PI data or bias existing in the training dataset, the model may remember it and generate response with customer data and the bias data. It mentioned paths can be adopted for data protection and cross-border data training. It also mentions paths is being developed. So which path technology and the way they are used should be carefully designed. And GDPR is the most stringent regulation in terms of privacy protection. And paths is considered as a strategic enabler of GDPR. When applied incorrectly, paths can be a crucial component to achieve data minimization and privacy by design. Organization can further improve its compliance by incorporating paths into DPIA data protection impact assessments. Okay, now what is paths? Paths ensure that user data is collected, processed, and stored securely, reducing the risk of data breaches and unauthorized access. Paths is designed to contribute the privacy preserving in several categories. It greatly helped to balance the privacy preserving and data utility. First, anonymization is a well accepted methodology to move the data from privacy regulations. It is supposed to completely remove the possibility that anonymized data be restored to the original data. For example, instead of redacting the PI data, you may choose synthetic data generation to remove or lower the reidentification risk, but still preserving the analytical insights and data utility capability for AI or LLM training. To get a better utility, you may choose pseudonymization. It provides end-to-end confidentiality and integrity for data sharing. In addition to data protection at rest and in transit, past technologies such as homomorphic encryption can ensure the data protection in memory and doesn't require decryption key before processing the sensitive data. However, the performance of homomorphic encryption is still a popular research topic in cryptography industry. Multi-party computing allows multiple parties to jointly process their data, but not allowing each of them to access all the dataset in plain text. Differential privacy is the first analytical data protection framework with mathematical proofing. It is effective for the most popular analytical query surveys such as average, max or mean, and count. It is pretty effective to some single out attack by adding noise before after data analytical calculation. Its efficiency for more complicated methods such as gradient optimization in deep learning is still being researched. Confidential computing protects data processing in memory. It allows higher trust being built to public cloud, computing platform such as Google GCP by secure the data access to the memory. It is often facilitated by hardware features such as Intel SGX technologies. In trust execution environment is also a hardware addition to counter the data tampering risk at hardware level. Hardware security module, HSM, and the ARM security trust zone are two typical products. FIPS 142 or FIPS 143 is used to regulate the tamper-resistant levels. Comparing to airport dock, we don't have a 100% reliable pseudonymization framework to ensure the data confidentiality and end-to-end integrity. I would worry more on the risk of quantum computing to AES than the risk that someday the dogs are taught to speak, so we know what exactly are in each of the passengers' luggage. And not to mention the cost for each of those technologies, such as homomorphic encryption, multi-party encryption, confidential computing, or differential privacy. We found that data anonymization may be an easier path to allow companies to get compliant by moving the data out of the scope of most of the privacy regulations by sacrificing some of the data utility or accuracy. Here are some pros and cons between multiple data anonymization methods. Comparing to pseudonymization, they all reduce the reidentification risk more or less. We found that synthetic data is able to achieve a better compromise between all criteria within privacy and data utilities. Depending on the data type, synthetic structured tabular data is normally created using a generative adversarial network, which we call the GAN. Unstructured data, such as text and videos, are normally generated using LLM. Now, after generation, synthetic data is passed to the downstream applications, such as cross-border data sharing, data usage at developer staging environment, LLM data pre-training, and post-training and data analytics. It is often assumed that the synthetic has no privacy issues, with slight quality degradation and fidelity degradation. The, the evaluation framework of synthetic data is important, that it cannot just provide feedback, allowing us to improve the generation process. It can also provide the transparency to get us to meet the regulatory compliances. SynEval is an open source code that we are working with Santa Clara University to evaluate synthetic data from different aspects, including fidelity, diversity, and privacy for both structured and unstructured data. Fidelity represents the utility of the synthetic data to the downstream data. Diversity represents if synthetic data provides sufficient entropy. For example, are we able to generate a five-star review with more diverse comments than just a good product? This product is good. Can we cover the comments in different sentiments, semantics, and lexical metrics? Privacy is essentially used to measure if the risk of re-identification risk from the synthetic data. It can also be used to measure the re-identification risk of real data. By combining different metrics, you may design different evaluation methods for your specific synthetic use case. At eBay, we're collaborating with Santa Clara University to design a synthetic data framework, which is called SynEval. You're welcome to try it at our public GitHub repository. And this slide shows an example showing the statistical similarity between a tabular numerical data and the synthetic data derived from it. And here we are demonstrating a combination of structured and unstructured synthetic data generation and the evaluation framework. The structured synthetic data is generated using GAN, the unstructured text is generated using LLM. First, let's interpolate the missing data rows with several methods we provided. And the real data comes from Amazon's publicly released product review data. We focus on four attributes, including rating stars, review title, review description, number of favorable votes for that review. Fidelity shows the fidelity evaluation results of the generation itself, such as stats, similarity of the synthetic data and the real data. Whether or not synthetic data looks like the real data in terms of the data range, mean value, sentiment, semantics, and so on. A utility shows whether the synthetic data can be useful as a replacement of the real data at downstream tasks. We trained a classifier to use review to predict the rating, for example. And diversity matrix shows if different range of data has been covered in synthetic data, and also if the synthetic data has sufficient entropy like the real data. Besides the structured data, we also calculate the diversity matrix for unstructured text data. And in these slides, we demonstrate a number of privacy metrics which we use to evaluate the re-identification risk from different aspects. If you feel we missed something, please comment it in our GitHub repo. And that's it. But before I wrap things up, please don't forget that the airport dogs are well ahead of us in terms of having the sniffing job done while keeping the customer privacy. I believe we still need to work to improve paths to address our customers' privacy needs. That concludes my sharing. Thank you, everyone. And feel free to reach out to myself, check out the GitHub repo, or read our paper about this work. Your suggestions are greatly appreciated.